All right, as promised, I wanted to make sure that I touched on and also went over this quiz review. So everything on this review will carry over to your quiz. Same thing as the quiz review from today as well. So it's kind of just making sure everyone's ready to go. My plan was to quiz on Tuesday today, but I think we needed an extra day. So for number 1 here, first thing you need to do is fill in the table, and that's where you're going to need Desmos. So let's see, I have a 4 parenthesis 2 and my parenthesis raised to the -2 power, and that gives me a 1. And then instead of the -2, I'm going to put in a -1, and I get a 2. Instead of the -1, I'm going to plug in a 0, and I get a 4. Instead of the 0, I plug in a 1, and instead of the 1, I plug in a 2. So there's my table. And then you need all of these different features of the graph. Well, if you don't see a graph, you're probably going to want to graph one. So I'm just going to sketch this real quick. Let's see, -2, 2, 3, 4, 5, 6, 7. See, -2, 1, -1, 2, 0, 1, 2, 3, 4, 1, 8, and 2, 16 is going to be way, way, way up there. So the graph is going to look like this. It's like going to go up, up, up. And then remember, when you are graphing these, it gets really close to the x-axis, but doesn't actually touch it. So now that we have it graphed, the domain and the range for all of these, actually the domain, the range, and the asymptote will stay the same for every single graph. So the domain is going to be -infinity to +infinity because you don't know how far it moves left and how far it moves right. So that's the domain. The range, how far down does it go? It gets really, really close to 0. And then how high up does it go? We don't know, so infinity. Y-intercept is really the only thing that you're going to have to actually look at the graph or look at your table to figure out. The y-intercept is this point right here, and it's where the graph is crossing the y-axis. This point is 0, 4. That's the y-intercept. And like I said, that's probably the only thing you actually need to think about. And then the asymptote is the line that your graph is getting really, really close to. And that is going to be the x-axis, which is y equals 0. So those are the key features. Your review today has you doing that again, twice actually, just to kind of get you used to it. But I wanted to get this out there to you so that you can see what to do. 2 and 3, you're going to be writing exponential functions. Exponential functions are y equals a times b to the x. A is your initial value or your starting value when your x value, it's the y value when x is 0. And then b is the pattern using multiplication. So starting value, pattern using multiplication. So like for number 2, the starting value, x is 0, the starting value is 4. And then b, the pattern to go from 1 to the next is 2. So your equation is going to be y equals 4 times 2 to the x. And that's it. Here, kind of the same idea. This one might be a little bit more difficult. Starting value is, see, x is 0, y is 1. Now you go from 4 to 1 to 0.25. So what are we multiplying by to get from 4 to 1 to 0.25? So one way to do this is to kind of go backwards, and instead of thinking about it using multiplication, how do I go backwards using writing things as division? So we know that if to go from 4 to 1, we're going to be dividing by 4. So remember, you do the divide by 4 and put a 1 on top. That's one way to do it. The other way is to take like the second point, y value, and divide by the point before that's y value. So you still would get 1/4. So whenever they're going down, it is a little bit more difficult. So you get y equals 1/4. 1/4 to the x. That's that equation. 4 and 5, is this linear or exponential? And then explain your reasoning. It's all going to be based on the pattern. Linear means that your pattern is plus or minus. Exponential means that your pattern is multiplication. That's really it. So if we take a look at number 4, to go from 6 to 3, 3 to 0, 0 to -3, -3 to 6, we are subtracting 3 each time. So this is linear, and the reason why is because the pattern is -3 or subtract 3. For number 5, to go from 3 to 9, 9 to 27, 27 to 81, 81 to 243, we are multiplying by 3 every time. So this is exponential. And the reasoning is that the pattern is timesing by 3. So up to there, that's all stuff from the kind of previous section. This is all from 6-2. Same thing, I guess, with number 6 as well. So I know that we haven't done this stuff in a while. We had a little bit of a break with the virtual week and things like that. So hopefully that makes a little bit more sense and is starting to come back to you a little bit. Number 6, it says the table shows the number of harmful bacteria in a lake sample. The lake will need treatment when there are 5 million bacteria or more. So 5 million is a 5 with 6 zeros, I'm sorry. So 5 million, that's what 5 million looks like. And you kind of need to make sure you know what that looks like because you're going to be having to do some predictions here. So first thing it says is to write an exponential function. So we did that here with tables. So we need to do that here with tables. So our exponential function is y equals, and we need to figure out what is A, what is B. A is the initial value. So we are starting with 1, 2, 5, 0. B is the pattern using multiplication. So to go from 1 to the next, we are multiplying by 4. So our exponential function is 1,250 parentheses 4 to the x. There's our equation. Now what it wants to know, if this pattern continues, basically it's asking how many days, or on day what, will we hit over 5 million? So it's kind of a guess and check thing. So 1250 parentheses 4 raised to the, see, at 4 days, we were at 320,000. So where are we at 5 days? We are at over 1 million. Let's try 6 days. At 6 days, we're over 5 million. So 6 days. After 6 days, we're going to need to do some treatment here. And that's it. 7 through 10 are probably my favorites because these are using exponential growth and decay. So you still do the same exact equation. Y equals A times B to the x. A is still the initial value. B, though, B is going to be the growth rate or growth factor, growth or decay factor, depending on what's going on. Now, if it's growth, you do 1 plus the rate. If it's growth, that's what you will be plugging in for B. If it's decay, you do 1 minus the rate. Notice on both of these, the 1 comes first. So you have to do 1 plus or 1 minus. And remember, with that rate, that's going to be given to you as a percent. You're going to have to move the decimal 2 places. So for number 7, it says there are 200 frogs and the population grows 9% each year. What is the growth factor? So for growth, I do 1 plus 9% is the same thing as 0.09. So the growth factor is either 1 plus 0.09, or you can write it as 1.09. That's what you're going to be plugging into your equation. So then it says right here, write the exponential equation to model this. So we have y equals, A is the initial value, so 200, parentheses, B is what I found up here, to the x. That's it. And then it says, predict how many frogs there will be after 8 years. Well, that's where you're going to need your calculator. So we do 200 parentheses 1.09 raised to the 8th power. So after 8 years, we're going to have 398.5 frogs. And if you had 399 frogs, that's totally fine, even though it's half a frog, but potato, potato. For number 8, we have Tony, and he's buying a car for $32,000. The value of the car decreases about 18% each year. So it's decreasing, which means it's going to be decay. When it's decay, we do 1 minus the rate. So if we have 18%, we take the decimal that's on the end here and we move it 2 places. So 1 minus 0.18, which let me show you what that looks like. If we do 1 minus 0.18, we get 0.82. So the decay factor is 0.82, and that's what we're plugging into the equation here. So we do y equals starting value, decay factor, to the x. And it says after 5 years, Tony decides to sell the car. Should he sell it for $10,000? Well, let's see how much his car is worth after 5 years. 32,000, parenthesis, 0.82, oh my gosh, 0.82 raised to the 5. So after 5 years, Tony's car is still worth $11,863.67. So if he sells it for $10,000, he's actually losing money. So should he sell it? No, it's worth more. That's all I'm going to put. All right, 9 and 10 are basically same kind of thing as 7 and 8, except for it doesn't really want you to go through all the different steps. So for number 9, you purchased land for $25,000. Each year, the value of the land purchase decreases 6%. If the trend continues, what will the value of the land be after 12 years? So we have y equals 25,000. Since it's decreasing by 6%, that means you're going to do 1 minus 6% is 0.06. 1 minus 0.06 is 0.94. So we have 0.94 to the x. And we're going to plug in 12 for x because we want to know how much it's worth after 12 years. 25,000 parentheses 0.94 to the 12th. And the land after 12 years is worth $11,898 and a penny. Because remember, money round to 2 decimal places. For number 10, it says you purchased your first home for $110,000. The value of your home increases by 8% each year. What is the value of the home after 6 years? So we bought it for $110,000. If it's increasing, that means we do 1 plus the rate. 1 plus 0.08 is 1.08. And that's what we plug into our equation. And we are going to plug a 6 in. So we have 110,000 parentheses 1.08 to the 6th power. So after 6 years, this is a pretty good investment here. Your house is worth $174,000. $174,556.18. So hopefully that clears that up a little bit. My plan is to put another video out going over the other review if needed. So kind of use this video to help you guide you through today's review. But any issues, please don't hesitate to reach out. Reach out sooner than later. I am a little bit busy tonight, so please reach out. Hopefully, like I said, a little bit earlier than some of you have been.